the functions whose values get repeated in a certain interval. Okay, so very well-known function we have. Suppose let me draw the graph of that function. It's a very well-known function, and to discuss periodic function, this is one of the easiest example to take. Okay, this is the graph of which function? It is the graph of sin x, right? So here we'll notice, suppose I'm taking one point out here. Any point we can take, but let me go for this point. Okay, this point seems to be again repeating here. Here, this point again seems to be repeating here again. Okay, why their values are same? Because this height is same, right? This height is going to be same, so their functional value are same. Okay, so if I consider this as x and this function as fx, so this one will be fx, x, fx. Then if I'll consider this value where it is first repeated, that length to be t. Okay, so this point from here to here, the coordinate of this point will be x plus t, so that this height will become f of x plus t. Okay, again this length is t, so x coordinate of this point will be x plus 2t, t plus t, and this one will be f of x plus 2t. So for this function, for this kind of function, what we are going to get, fx will be equal to f of x plus t, will be equal to f of x plus 2t, and so on. Right? This way also, if I consider another t here in the left, we are going to get the same thing again. Okay? So this kind of function are called periodic function. Okay? With period t. Okay? So why we are not taking 2t? Actually there is a difference between period and fundamental period. We'll call that one to be the fundamental period of a function. We'll call fundamental period to be that value of those intervals which is least and positive. Least positive value. Okay, so fundamental period of a function is the least positive value for which the functional value gets repeated. Okay, so this is the definition of what is it called? Periodic function. And for our example, this t is nothing but 2 pi. For sin x gets going repeatedly in an interval of 2 pi, and that is the smallest value for which it is repeating. So 2 pi is the fundamental period of sin x, we call that. Okay, so basic definition is this. Okay, generally 7 functions out of them. 7 functions out of all those functions which we encounter generally are only periodic functions. Rest of all are aperiodic, means non-periodic. What are those 7 functions? The 6 trigonometric functions, and the fractional part function. So basically these functions are only periodic or their combinations. Okay, combinations means compositions, product and difference, sum. Only those functions are periodic. Rest all the functions are aperiodic functions. So first thing we need to learn, we need to know this. Then we'll try to remember some standard results. Okay, for that standard result I'm making one table. This table will help us to remember a few standard property. So I'm writing here the functions, value of n, some values of n will come, and we'll try to write period if at all they are periodic. The first thing we need to know is sine to the power nx, cos to the power nx, and their reciprocals, that is cosec to the power nx and sec to the power nx. When value of n is odd, the period remains the same, that is original period 2 pi. Okay, and when the value, that exponent, is even, the period gets reduced to pi. Okay, this is the first result we'll try to remember. Okay, the next is tan to the power nx and cot to the power nx. Okay, here it is even or odd, doesn't matter. For both the cases, the period is pi. All functions are periodic with these periods. Okay, the next thing is fractional part of x. Okay, the value of n here, there is no value of n, and the fundamental period is 1. Okay, and then the next thing we need to know, sine to the power 4x plus cos to the power 4x, or tan to the power 4x plus cot to the power 4x, or sec to the power 4x plus cosec to the power 4x. When the functions are complementary and then their power is even, can be to the power 8x, sine to the power 8x plus cos to the power 8x, whatever the even value. Okay, the fundamental period is pi by 2 always. Now some of you are maybe thinking, what about sine square x plus cos square x? I'm coming into it. Okay, the next point is that only. Okay, the fifth is fx equal to c, constant function. Okay, no fundamental period. Does not exist. Okay, so these are the few things, along with, I'm extending this table again. Okay, these are few things we need to remember. Okay, before we proceed with the periodic function. Okay, constant function does not have a fundamental period, and period does not exist. Sine square x plus cos square x, we know it to be equal to 1, so ultimately it will be a constant, it will act like a constant function. So in that case we'll say that the fundamental period is no fundamental period, so period does not exist. Okay, that will be the answer. For rest of the even powers, okay, the period will be always pi by 2. Okay, along with this we'll just write one more we are adding along with this 5, so that we proceed with the next sixth one is sin x, modulus of sin x plus modulus of cos x kind. Okay, again the period is pi by 2, but this one is true for all the complementary functions. Modulus of tan x plus modulus of cot x, modulus of sec x plus modulus of cos sec x plus cosec x, modulus of sec x plus modulus of cosec x also will be pi by 2. Okay, so these are the basic things we'll try to remember. Okay, along with a few property. Okay, property 1 is, if fx is periodic, then 1 by fx and root over fx also will be periodic. Again, property 2, if f and z be two periodic functions, then f of z and z of f will also be are also periodic. But here one thing we need to understand, when f and z are periodic, f of z will be periodic, but not necessary that the period of f of z will be same as period of z. Similarly, z of f is periodic, that is correct, but not necessary that z of f, the period of z of f is the period of f. Let me take one example. Suppose I am taking cos of sin x. Suppose I have to find out the, what is it called, period of cos of sin x. So what will it become? Sub sin x का period क्या है? 2 pi. So it seems to be, if I follow this, it seems to be the period is 2 pi. Okay, but we'll notice that f of x plus pi is cos of sin of x plus pi will be equal to cos of sin x, right? Cos of pi plus x will be minus sin x. Cos of minus sin x is x. So cos of sin x, showing us that this one is fx again. So I'm getting the fx will be equal to f of x plus pi, and pi is less than 2 pi, right? So 2 pi is not a period for this function. In fact, pi will be the period of this function, because that is the least positive value for which we are getting f of x equal to f of x plus pi, right? So f of z and z of f will be always periodic, but not necessary that period of z of f will be f or period of f of z will be z. Okay, we'll go for the next property. Okay, if f and z be two periodic functions with period t1 and t2 respectively, then f plus minus z, f into z, f by z, if it is defined, not necessarily periodic. Okay, if there are two functions f and z which are periodic functions with period t1 and t2 respectively, then f plus z or f minus z, f into z, f by z are not necessarily periodic. They may be periodic, they may not be periodic. Okay, and in this case, to check whether they are periodic or not, okay, what we'll do, we'll find out period of this. Suppose I am taking the period of this as t. The period of this functions, that is t, will be evaluated like this. Okay, LCM of numerator of t1 t2, okay, divided by HCF of denominator of t1 and t2. Okay, I repeat again this property. This is very, very important, and we are going to use quite many times. If f and z are two periodic functions with period t1 and t2 respectively, then f plus minus z, f into z, f by z are not necessarily periodic. Okay, in order to check whether they are periodic or not, and if periodic, what is the period? In order to find that, what we'll do, suppose their period I have taken as t. So in order to find t, what we'll do, we'll find out the LCM of the numerator of t1 and t2, and HCF of, will divide by the HCF of the denominator of t1 and t2. That is how we'll find out the period of two functions which are given either of these three forms. Okay, then let us go for one example of this. Okay, let us take one example of this. For example, Suppose I have to find out, for example, let us take one example. Suppose I have to find out period of sine of 3x by 2 minus cos of 5x by 3. Suppose I have to find out the period of fx. Okay, so which is difference of two functions. Okay, so we'll take the period of this one as t1 and period of this one is t2. Okay, now t1 3 by 2 into t1 will be equal to 2 pi. I hope you have understood this. I have used the period of sine x is 2 pi, right? So in order to get the period of 3 by 2x, we have to divide the period of 2 pi by that factor. I just want you to understand one thing here. Okay, suppose sine x, the period is here from 0 to 2 pi. So if I ask you to find the period of sine 2x, so what actually happening? Sine 2x, what will happen? In the interval of 0 to pi, it will take 2 turns. So the period of sine 2x becomes pi because the whole curve has been squeezed to half of it. Okay, so when from here we need to understand one thing. If there is a function fx with fundamental period t, and if I have to find out the period of f of x, f of ax, then that one will be equal to t by a. In fact, it will be t by mod of a. Okay, this thing we need to understand. I'm just giving you one example. Sin x and sin 2x. Okay, sin x was still here 0 to 2 pi. The moment we are drawing sin 2x, it gets repeated in the interval pi. So its time interval reduced to pi. Okay, understood? So that is what we are going to do. So what I am exactly is the same thing I'm doing here. So t1 will be equal to 2 pi by this 3 by 2, and I'm writing it like this. So t1 will be equal to 4 pi by 3. Okay, now we'll try to find out that one, t2. t2 will be 5 by 3, t2 is 2 pi. So t2 will be equal to 6 pi by 5. Just now we have said. Now, so what we have, in order to get the period of fx, what we'll do? We'll take the LCM of these two and HCF of these two. Okay, so period of fx, let us take that one to be t. T will be equal to, let me write it here, LCM of 4 pi and 6 pi by HCF of 3 and 5. Okay, so highest common factor of 3 and 5 is 1, and LCM of 4 pi and 6 pi will be 12 pi. So fundamental period of this function is nothing but 12 pi. And this is how we calculate.